Hello and welcome back to the channel. If you're new, please don't forget to subscribe. And each week on the Ant2Me website, I offer every viewer the chance to vote on what next week's topic is going to be. So please don't forget to do that. Now, on to Venn diagrams and tree diagrams.
What are they all about? Venn diagrams, tree diagrams help us visually depict probability and probability events in a very clear and very concise manner, which allows us to calculate and solve quite complex probability questions in a clear and simple manner. So let's have a look at what they're all about. So you might have seen Venn diagrams before. They look like this, the box with two circles in them, where this might be event A and this event B. So what this does is it relates multiple events together. So how we see this is this area that I'm shading in green. So where A and B both exist. This area in black is just B, and this area in red is just A. So this tells us how A and B relate to each other. Now this can help us with mutually exclusive and non-mutually exclusive events. So a mutually exclusive event is an event that doesn't have any overlap on a Venn diagram. So that's not the official definition, but I think it's quite an easy way to think about it, because what it is it's a box like this with one circle and no overlap. Okay, so they are two events that have nothing in common with each other. Non-mutually exclusive have an overlap. Again, not the official definition, but it's a nice, easy way to think about probabilities. So this has an overlap right here between, let's call it A and B, which means they're non-mutually exclusive. So now we can know using this, we can figure out the probabilities of A and B, and A and B by themselves with data, of course. And if you're ever told information about mutual exclusiveness or non-mutual exclusiveness, then you can picture or draw a Venn diagram to illustrate that to help you solve the probabilities. Now, what about tree diagrams? So tree diagrams look like this. They help solve multi-step events. So if we have step 1, where we have the options B or A, or why don't we say heads or tails? And then step 2 is heads or tails again. So we flip a coin twice. This tree diagram can help us calculate the probabilities for those. So when we flip 2 heads, we have 3 or 4 possibilities. So you can have tail heads, and then tail tail. We can have heads tail, and heads heads. So we have 4 possibilities. Let's just redraw that. 4. So we have 4 possibilities, and the probability of these 4, so heads, heads, the probability of that, plus the probability of heads, tails, plus the probability of tails, tails, plus the probability of tails, heads, is going to equal 1. Why is this? In the first math nugget, I explained that for something to have a probability of 1, it's always going to happen, and the probability of getting any one of these is 1, because the probability we get no heads or no tails or nothing is 0. Hence, the probability of all of this is 1. So, the probability of getting heads, heads, is going to be the probability of heads here times the probability of heads. So you might remember your teacher telling you, so you times the probability of heads and then you do that again. And that's the case. So that's 0.5 multiplied by 0.5, or half or 50% multiplied by 50%. Now, that's the case for all of these. So 50% times 50%, 50% times 50%, 50% times 50%. So each one of these events is equally likely to occur, and they all add up to 1. If you want to make this even more complex, you can add 3 layers to it. Heads, 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 tails, heads, tails, and then for each of these, you can add 1 more. This is called a 3-step probability, and the same rules apply. So to find the probability of this branch, for example, you would go heads times heads times heads, and that would give you that probability. And then again, if you did that for all of them, they would all add up to 1. Great, so I hope that's given you a nice little math nugget to think about with your probabilities. I'll see you next week. Please don't forget to go on the Answer Me website and vote for what topic you'd like to see next week. Thank you very much.